Hello, welcome to the fourth day of our lesson. Today we're going to learn how arccosine can help us find the value of an angle. So we're going to start with what we left off with on the previous lesson. Let's draw and label two triangles where the following is true. Cosine of theta is 1 over 2. So this is the adjacent and this is the hypotenuse. So both of them are positive. We'll have 1 over 2 and 1 over 2. Cosine is going to be negative in these two quadrants, so we don't even need to draw those triangles. So these are the two triangles where it's true. So if I draw the other side, across from the root 3, it's 60 degrees. So our reference angle is 60 degrees. So if we want to find the values for theta that make this true, it'll be 60. I should put a 0 there. This is 300. And then this doesn't give us a limitation. It doesn't say find all the values between here and here. It just says we just have to find all the values. So we have to keep going. If I add 360 to this, 60 plus 360 would be 420. Add 360 to this, I get 660. And it keeps on going and going and going, and we have an infinite number of values. So an easy way to do this is we could say it's 60 plus 360k and 300 plus 360k, where k is any integer. And the integer could be positive and it could be negative. Now, how do these two angles relate? 60 and 300. Well, this is a positive 60 and this is a negative 60. We could have also said that this one here is negative 60 plus 360k. That would have given us the same information. All right, let's look at this one. Cosine of theta is equal to negative root 3 over 2. Let's first draw the triangles. So now it's negative, so it'll be on this side. So negative root 3 over 2. So this is going to be negative 1 and 1. So across from that, it's going to be a 30-degree reference angle. And so this will be 150. And this over here is going to be 210. So if we look at this, we'll have 150 plus 360k, and we'll have 210 plus 360k. Those are our values for theta. Now, how does this relate to inverse cosine? So the inverse cosine would just be 150. Notice that's 150, and that's 150. So I could write the second one as negative 150 plus 360k, because negative 150 is coterminal with 210. So I could write this as plus or minus 150 plus 360k. Just like on my previous problem, I could write this plus or minus 60 plus 360k. Now if we look at something like cosine of theta equals negative 2 over 5. So negative is going to be on this left side again. Negative 2 over 5. That's supposed to be a negative 2 in there. You can't see it. I should draw my triangles a little bigger. So if I want to find my theta, our theta is this value there. Now, I don't know this angle because this isn't one of those neat triangles that we know the angle right away. So first, let's find the inverse cosine of negative 2/5. Now I'm going to plug this into my trusty calculator, inverse cosine of negative 2/5, and my answer is 113 degrees. So 113, let's say 113.6. Well, if we do what we did in the previous problem, we'll know that this is 113.6. So all my values for theta can be written as plus or minus 113.6 plus 360k. That way we can write two different equations all in one, and it looks a little bit neater. Let's do that for 3/7. 3/7 are on this side, or our adjacent is 3, our hypotenuse is 7. And so if I want to find this, first I need to find the inverse cosine of 3/7, which is 64.6. So now that I have that, this will be plus or minus 64.6 plus 360K. Any questions with that? I don't know why I asked. You can't answer anyway. I'm just so used to asking if there's any questions. All right, let's do this. Let's draw and label the two triangles and then find the value of x. The only difference here is instead of degrees, now we're dealing with radians. So if I look at this first one, it's positive, so it's in this right-hand side. This is going to be 60-degree angles, so this is going to be pi over 3, and this is going to be 5 pi over 3, and 5 pi over 3 is the same thing as negative pi over 3. So I can write my values of x being plus or minus pi over 3. Now instead of 360, I'm going to add 2 pi each time to get my coterminal angles, so it'll be 2 pi n. For my next one, negative root 3 over 2. I'm learning my lesson to draw some bigger triangles. We have negative root 3 over 2. Now this other side is going to be 1, so that means the reference angle is going to be 30 degrees. So this will be 5 pi over 6. This would be 7 pi over 6, which is the same thing as negative 5 pi over 6. So if that's 5 pi over 6, that's negative 5 pi over 6. Let's write this as plus or minus 5 pi over 6 plus 2 pi n. All right. Now, if we have cosine of x equals negative 2/5 pi, or negative 2/5. Now, this is in radians because that has an x. So we have 2/5. So the first thing I need to do is turn my calculator to radian mode. And now I do the inverse cosine of negative 2/5. And my answer of inverse cosine of negative 2/5 is 1.98. Now this might be a little confusing to people going to radians because a lot of times when we're dealing with radians we deal with pi's. Well, in pi, if we write pi's out as a decimal, this is going to be 0, this is 3.14, this is 1.57. So it does make sense that 1.98 would be somewhere between pi over 2 and pi. So 1.98 does make sense for this area. But if that's 1.98, we know this is going to be negative 1.98. So I can write my values of x being plus or minus 1.98 plus 2 pi n. So if I do 3 over 7, that's going to be a 3. Those are 7s. Inverse cosine of 3 over 7 is 1.127. Or say, let's 1.13. Leave it at 2 decimals. And so my values for x are going to be plus or minus 1.13 plus 2 pi n. That's supposed to, I'm going to fix that. That bothers me. All right, plus or minus 1.13. All right, now I hope that makes sense for people. What we're doing is we're actually taking the arccosine when we do this. Arccosine gives us an infinite number of solutions for the value of an angle. If we have theta, we're going to have to add 360n. If we're dealing in radians, we're going to have to add 2 pi n to get to our other values. This is an important formula, so this is good to have down in your notes. Now, interval notation, we've been talking about this throughout the year. But this is saying theta is an element that is between negative 360 and 360, but it doesn't include. That's what the parentheses mean. It doesn't include the ends. If I use brackets, that means it can include negative 360 and 360, and we call that a closed interval because it contains the edges. So if I want to find the arc cosine of 0.7 between negative 360 and 360, and we're including the ends, we know arc cosine is plus or minus the inverse cosine plus 360n, because we're dealing in degrees. So we just have to take the inverse cosine and make sure our calculator is in degrees, because we have theta. Inverse cosine of 0.7 is 45.6. So I have plus or minus 45.6 plus 360n. And now is the trick to actually find the values that we're looking for. We want to, so it says find the general solution. This right here is the general solution. Now we want to find the specific solutions for this given interval. So we know 45.6 will work. We know negative 45.6 is in that interval. Now if I add 360 to 45.6, that's more than 360 degrees. If I add 360 to negative 45.6, negative 45.6 plus 360 will get us to 314. So that's another value, 0.4. Now, we can also put in a negative one for n, so that's like subtracting 360. So 45.6 minus 360 is negative 314.4. So we have all of these answers that are going to be able to work for theta between negative 360 and 360. Now, if we're dealing in radian mode, it's the same exact deal, but with the parentheses and the brackets. Parentheses mean that it doesn't include the ends. Brackets mean it does include the ends. So if I say x is equal, that's an indication that it's in radian mode. So I'm going to do plus or minus the inverse cosine of negative 0.3 plus 2 pi n. Now I make sure my calculator is in radian mode, and I take the inverse cosine of negative 0.3. My answer is 1.875. Let's just say 1.88 plus 2 pi n. I forgot my plus or minus out in front of here. Now I want to find all the values between 0 and 4 pi. So 1.88 works. If I add 2 pi to that, I'm going to get 8.16. Now 4 pi, 4 times pi is equal to 12.56. So this goes from 0 to 12.566 and so on. So this gives us an idea of how big of a number we can go up to. If I add another 6.28 to this, it'll be 14 point something, which will be over. So that's as far as I can go with those x values. Now if I look at negative 1.88, that doesn't fit in this interval. But I can take negative 1.88 and add 2 pi to it to get 4.4. Now I can take and add 2 pi to that to get 10.68, or 10.69 would probably be a good way to round it. And now if I add another 2 pi, I'm way over. So these are my 4 values that will work for x in this particular situation. All right, hopefully that's enough to get you through your homework. Good luck.